we are now going to look at the properties of gaseous exchange surfaces. The properties that enables gaseous exchange to take place. Those are the properties of the surfaces where gaseous exchange takes place. Now, we know that gaseous exchange takes place in the lungs, it takes place in the alveoli and the blood capillaries. So almost all our properties are going to be based on those ones. First of all, the trachea and the bronchi have capillary rings. They have got capillary rings. That tube which we call the trachea and the bronchi, they are circular, and outside they have got capillary rings. The capillary rings, they keep the trachea and the bronchi open. They keep it open. The strength of the capillary is the one that keeps the trachea and the bronchi open, and they also prevents the trachea and the bronchi from collapsing in and closing the gap. Now the inner passage aligned with the mucous membrane, and also the inner passage, they also have cilia's. These ones prevent the entry of dust in the lungs. The mucus will trap the dust, and the cilia's will force the dust to come out of the trachea so that it can be coughed out of the system. The mucous membrane has a rich supply of blood, and this rich supply of blood keeps the incoming air warm and moist. That is the supply of blood. The epiglottis also plays a function of preventing food, drinks, and other solid substances from entering into the trachea. So the epiglottis will close when food is going down the gut, when water is going down the gut. It crosses the air pipe to prevent those substances from entering into the trachea. And the lungs have numerous alveoles. They have numerous alveoli. And because of the numerous alveoli, this means that the lungs have got a large surface area for gaseous exchange. That is another adaptation. And then the layer between the blood capillary and the alveoli is very thin. The layer is very thin, meaning that it facilitates the passage of gases across the membrane. Then also the lungs are spongy. Being spongy allows the lungs to expand and easily contract, in the process allowing the inlet of air and outlet of air. There is a high density of blood capillaries in the alveoli. They are supplied with a high density of blood capillary. This one facilitates the faster diffusion of gases into the blood and out of the blood, and a faster movement of the blood, and also movement of the blood to the tissues. Then, still the epithelial lining of the lungs is covered by a thin layer of moisture. That is the epithelial covering of the lungs, covered with a thin layer of moisture. This thin layer of moisture allows the dissolving of oxygen into the moisture so that it can easily diffuse across the membrane into the alveoli. Then the connection of the lungs to the trachea, bronchi, and the bronchioles. This facilitates the flow of air. Connection between the lungs to the trachea, to the bronchi, and the bronchioles. And lastly but not the least, the lungs are covered with a pleural membrane. A pleural membrane prevents mechanical injury to the lungs. So we have been talking about the properties of gaseous exchange surfaces. We have seen that the trachea and the bronchi have got cartilage rings which prevents them from falling in, and it keeps them open. We have seen that the lungs are covered with the pleural membrane which prevents mechanical damage to the lungs. We have seen that the epithelial lining of the lungs has got a thin layer of moisture covering it, which facilitates the dissolving of oxygen for easy diffusion. And also, we have seen that the epithelial lining of the alveoli and blood capillaries are very thin. This allows them to allow gaseous exchange to take place. And another one is that they have a high numerous alveoli. The lungs have got numerous alveoli. This increases the surface area because they are very many. And we have seen that the epiglottis also takes part in the controlling the inlet of food, water, and other substances into the trachea. And we have seen that the mucous membrane has a rich supply of blood to keep the incoming air warm and moist. And lastly, not the least, the passage aligned with the mucous membrane and the ciliated muscles, which prevents the entry of dust in the lungs. That's what we can talk about the properties of gaseous exchange surfaces. Next time, we are going to look at artificial respiration. Please continue to study with us.